Welcome students, very happy to interact with you again. In the coordination compounds, we will continue with the discussion of textbook exercise now. As isomerism and other parts are deleted, the textbook exercise constitute only a mediocre part as far as practice problems are concerned. Correct? Now, we will continue with the discussion. Question number 7, 9.7. You are given formula asked to name according to IUPAC norms. Okay. Formula, name, formula, name, formula, name. I think what are the important highlighted points that I have mentioned to you. First, you should identify the type of the complex. You have to split the complex and find out the charge of the central metal ion. After that, check the coordination number. After that, identify the counter ion. Counter ion should be named and it should not be numbered. Correct? Now here, except for one example, for rest of the example, I want to tell you directly, because I consider that we have done exhaustively the IUPAC nomenclature. So I give you the correct answer. You verify whether we have written the answer. You verify whether the given answer is correct or not. Okay. First one, CONS36Cl3. I think this example we have discussed several times. Complex cation, simple anion type. Coordination number 6. Correct? So cobalt oxidation number will be 3. So what will be the naming now? Hexaamine cobalt Roman letter 3 chloride. Kindly don't write trichloride. Okay. And in this example I want to work out. Let me come to it finally. TaH2O6 3+. This ion is well known example. I think even in the test I asked this question. It is a purple color. If water is removed, it is colorless. T2G1EZ0 to T2Z0 EG1 transition. TaH2O6 3+ now. That is the DD transition. That ion. Hexa aqua titanium Roman letter 3 ion. Fourth one, CONS34Cl NO2Cl. First you check whether the given formula is correct. NH3 4 times polyatomic molecule, so we put the bracket Cl, and NO2 is also in bracket, correct. Coordination number 6, 4 plus 1 5, 5 plus 1 6. NO2 they have given. I already informed you, if it is not specified, you take it as nitrito N. So according to the alphabetical order, tetraamine and then chlorido. This is nitrito -N-. This part is very important, correct? Nitrito -N- cobalt Roman letter 3 chloride, correct? Right. Next, MnH2O6 2+. Manganese oxidation state is obviously +2. What is the reason? Because it's a neutral ligand. So hexa aqua manganese Roman letter 2 ion. Kindly don't write manganate. You will write manganate only if it is anion. It is cation. And here nickel should not be called as nickel, nickelate. It's a very obvious example. sp3 hybridization tetrahedral shape. Correct? Tetrachlorido nickelate Roman letter 2 ion. Correct? And here hexaamine nickel Roman letter 2 chloride. Don't write dichloride. Next, this example I think we come across this example in the nomenclature itself now. What is the specialty? COEN3 3+. It's a bidentate ligand. So 3 ligand is equal to 6 donor atom. Since the name itself contains a numerical suffix, you call it as tris. Close the bracket. Ethane 1,2-diamine. Cobalt Roman letter 3 ion. And this is this one several times we discussed. Tetracarbonyl nickel 0, because X plus 0 is equal to 0. So in all the metal carbonyls, oxidation number will be 0. NaCO4 tetracarbonyl nickel 0. If it is FeCO5, how would you call pentacarbonyl nickel 0? Correct? Right. This one I am planning to work out for you now. What would be the reason for that? Now, here platinum is very easy. That is no NH3Cl. What is this NH2CH3? NH2CH3, which is nothing but CH3NH2. What is that? Methylamine. Methylamine. It's a ligand. It is neutral. It is neutral. This alone is anion. Shall we write this? Pt NH32Cl NH2CH3 Cl. It ionizes to give Cl minus. This will be plus. So Pt NH32Cl NH2CH3 whole bracket plus Cl minus. Correct? Now this is X neutral. Cl is minus 1. X minus 1 is equal to plus 1. So X is equal to plus 2. So platinum is present in Roman letter 2. Correct? Now you check the naming. Diamine, then chlorido, methylamine, correct? Platinum, Roman letter 2, chloride. Again, these kind of silly mistakes are committed only the students who are supposed to do very well in the examination. What is it now? Here methylamine, METHYL, AMINE. Here some of you inserted double M. Methylamine. No, methylamine only. Similarly here also, where I have written this tris ethane 1,2-diamine. There also DIAMINE only. Not you write AMMINE only for NS3. Correct? So why I am reiterating this again and again, repeating again and again now, this correct idea should be properly fixed up in your mind. That is why I am repeating it. Okay. Now we are going to discuss very interesting questions, concept based questions. Question number 13. Aqueous copper sulfate solution is blue in color. Aqueous copper sulfate is blue in color. Aqueous copper sulfate. You know very well that copper sulfate aqueous is this CuH2O4 SO4, where the blue color is due to this ion CuH2O4 2+. Very important. If anybody asks you what is the reason for blue color of copper sulfate solution, not due to SO4 2- ion, it is due to CuH2O4 2+. Especially entrance going children, you should remember. The bright color of copper sulfate solution is due to the presence of the complex cation tetra aqua copper Roman letter 2 ion. Correct? Here, to this copper sulfate solution, they are performing two experiments. First, potassium fluoride is added. Next, potassium chloride is added. The question is, A. Green precipitate when potassium fluoride is added. Bright green solution when potassium chloride is added. You have to explain. See, there is a change in color from blue to green. From blue to green. In one case it is bright green. In one case it is a precipitate. In another case it is a solution. Correct? How you are going to explain this now? Perhaps I do not know the sequence of the video. In one of the video, we discussed that change of the ligand will definitely bring about change in the color. Correct? In the case of aqueous copper sulfate, H2O is responsible for, H2O ligand is responsible for blue color. Now, we are adding potassium fluoride, KF, where which ligand is present? F- ligand is present. In KCl, Cl- ligand. So you have to think in the other way around. Oh, in potassium fluoride, F- is there. In potassium fluoride, Cl- is there. Now what is happening now? Neutral water ligand, aqua ligand is replaced by F-. In another case also, the neutral water ligand, aqua ligand is replaced by Cl-. So ligand displacement take place. Ligand is getting exchanged. Automatically water aqua is replaced by F-. In second case also, H2O is replaced by F minus. Automatically, surely I tell you, the complex cation will become now complex anion with the same coordination number 4. Now let us explain the result. In the case of KF, CuH2O4, SO4 ma, we need to bother only about the ligand. We are not balancing the equation ma. 4H2O replaced by 4F minus. Since it is anionic ligand, automatically the charge will change. Correct? How will you find out the charge? Copper is plus 2. Correct? So, copper is plus 2, 1 fluorine minus 1, 4 fluorine minus 4. Minus 4 is equal to overall charge how much? Minus 2. So, I think our answer is correct. CuF4 2 minus. Because in examination, students will get the panic. Sir, I do not know how to write the charges or how to write the charges. Very easy. CuH2O4 SO4 2 plus. Correct? Or you can write Cu. Man, just for you to understand, I have written SO4. You need not bother about SO4. Man. You put 2 plus here. You can write this as, I think, you can erase this. And here what will be coming out? SO4 will be coming out. So remove this. You put 2 plus. H2O will be replaced by F minus now. Automatically you get CuF4 2 minus green color. So water aqua ligand is replaced by F minus. So blue is changing to green. I think NaH2O 6 2 plus. That one is replaced by ethane monodiamine. You get pale blue color, and then finally you get purple color. Correct? So change of ligand. Here also the same. Similarly, H2O is replaced by Cl minus. Again the charge 1 chlorine 1 minus. Plus 2 minus 4 is equal to minus 2. So what is the ion complex anion? CuCl4 2 minus. CuCl4 2 minus. Correct? So what can you name this complex? Tetrafluoridocuprate, Roman letter 2 ion. This is tetrachloridocuprate, Roman letter 2 ion. So we come to a conclusion that blue color copper sulfate solution, by changing the ligand, it becomes what? Green. At this juncture, I would like to share this with you, one important feature. In salt analysis, aqueous copper sulfate blue, aqueous copper nitrate blue, whereas copper chloride is green. You check, you will be given a green color copper chloride salt. So again, proving that. Correct? Copper fluoride green. Correct? I do not know whether you have got an exposure to qualitative analysis in the lab. Green color salt and blue color salts are called as copper salt in the preliminary analysis. Okay, ma? Right, ma? Question number 9.4. Let me read out the question. What is the coordination entity formed when aqueous KCN is added to copper sulfate solution? Ma, potassium sulfate is, copper sulfate is added with KCN. What is the coordination entity formed? If you are really my beloved student, by this time your answer would have been ready. Copper sulfate, potassium cyanide, what ligand in a CN minus ligand? You need not verify the answer. Shall we work out here? Copper is 2 plus bar, Cn minus. Copper coordination number how much? 4. Correct? Actually, Cu, correct? Cn 4. Blindly, suppose you are forgetting in the examination, this is one of the easy way. What will be the overall charge? Copper is plus 2 bar. 1 Cn 1 minus 4 Cn minus 4 is equal to what? Minus 2. So the answer is 2 minus. So the question is, what is the coordination entity formed when casein is added to copper sulfate? Now, don't verify this answer. So this is the coordination entity, CuCN4 2 minus. CuCN4 2 minus. To get some satisfaction, I have given the equation. What is the equation? Copper sulfate, excess of potassium cyanide. K and SO4, you get K2SO4. Correct? So another K, totally 4K. So another 2K will join here because this ion is 2 minus. Here 2 plus only you know. Now 2K plus. So K2CuCN4. The question is, what is the complex entity, coordination entity? You should mention this only. This is the coordination entity. Suppose in examination you are forgetting, you write like this: Cu, Cn 4 times. Correct? This is plus 2 minus 4 minus 2. CuCN4 2 minus. Correct? Can you name this coordination entity? Tetracyanido cuprate Roman letter 2 ion. What is the name of this complex? Potassium tetracyanido cuprate Roman letter 2. The question is, what is the coordination entity formed? Correct. Why is there is no precipitate of copper sulfate when H2S is passed through the solution? Beautiful question, ma. See, to this, actually copper sulfate is mixed with ACN. Here, especially this question should be approached in a different angle. How we have to approach the question? First of all, listen to me very carefully. Correct? How you have to approach the question? I do not know whether you have done salt analysis in 11th. First group reagent dilute HCl, second group reagent H2S, third group ammonium chloride ammonium hydroxide, fourth group ammonium chloride ammonium hydroxide H2S, fifth group ammonium chloride ammonium hydroxide ammonium carbonate, sixth group ammonium chloride ammonium hydroxide, this is what diammonium phosphate. Correct? That is sixth group reagent. We don't go up to that much. In the case of group 2, in group 2, what are the substances, basic radicals present? Copper. Copper is one of the predominant species. When the group reagent is H2S, I am talking about qualitative analysis. In second group, you pass dilute H2S, you get black precipitate. You know the reason why? I tell you, copper 2 plus kana. Remember, copper 2 plus hydrogen sulfide is H2S. In H2S, what ion is present by S2 minus? Copper 2 plus S2 minus combined together to give CuS, which is copper sulfide black precipitate. Correct? Now let me tell you, this is copper sulfide solution. Basic copper sulfide solution through which you pass H2S. What happens now? H2SO4 comes out. So you have CuS plus what? H2SO4. Correct? Actually, I do not know why they have framed the question like this. The question should have been, I tell you, to an ordinary copper sulfate solution, hydrogen sulfide is passed, black precipitate is obtained. To the same copper sulfate solution, potassium cyanide is added. Correct? Potassium cyanide is added. Now, to the resultant solution, H2S is passed. No black precipitate is obtained. Why? So that should be 9.14 question. I am not finding fault with the way they have asked, but from students' perspective, how you ought to understand the question. Correct? See, this is called group analysis. See, in first group, dilute HCl, white precipitate is obtained, lead is present. Why was? What is the reason for white precipitate in group 1? Many of you will blink. Very simple, ma. First group lead, Pb2 plus. Hydrochloric acid contains Cl minus ion. Pb and Cl, you get PbCl2. PbCl2 is what? Lead dichloride or lead chloride, which is white in color, white precipitate, insoluble in water. That's how you have to answer. So the question is, through copper sulfate solution, hydrogen sulfide is passed. So, through copper sulfate, hydrogen, you get a black precipitate of copper sulfate, agreed. But to the same copper sulfate solution, potassium cyanide is added. Correct? After that, H2S is passed through the solution, no precipitate is obtained. Why? I hope you understand. Why now? The reason is, when copper sulfate combines with K2 potassium cyanide, you get a complex now. So, copper combines with the ligand called Cn minus to form a non-ionizable coordination sphere called tetracyanido cuprate Roman letter 2 ion. Now, in this solution, if you pass H2S, no precipitate. What is the reason? Copper is bound to Cn minus in the form of non-ionizable species. Hence, no black precipitate. Correct? I think I have given an elaborate explanation. Hope you would have enjoyed. So, this is the way you ought to write the reply. Next, I am going to discuss question number 28 and 29. They are all MCQs. Actually, in the revised question paper pattern, you have more MCQs, it seems. That is why I am doing these two. And it is the observation for the past several years that 95% of the questions are from textual exercise only, as far as chemistry is concerned, and in text and the solved examples. That is why The entire exercise and the in-text questions I am going to do in a short video, okay, so that you can pause and view, again you can pause and view, and you can practice more. That is why there are some videos which I make it very lengthy, the theory video, especially the question answer type. Let me make a 20 minutes video or 25 minutes video. Let it be a shorter one so that you can view it again and again, correct? Even in this video, I made a shorter version only. In question number 28, this is the complex given, CONS36Cl2. They have given 4 options. How many ions are produced from the complex? Correct? Don't follow inky pinky panky. Now let us split the complex. Even you split Cl2, 2Cl minus and 2 plus. Correct? So how many ions now? 1 complex ion, 2 simple ion. Altogether 2 plus 1, how much more? 3 ions. So I think option C is correct. 3 ions are produced. 1 complex ion, 2 simple ion. In this case, which is the counter ion? This is the counter ion. Next, question number 29. Sorry, not 29. Question number 30. Wrongly marked. Question number 30. This is not 29. This is 30. In this question, the oxidation number of cobalt in KCOCO4. KCOCO4 is the complex. KCOCO4. What is the oxidation number of cobalt? Now this is the complex. You split K plus COCO4 minus. This is cobalt. This is carbonyl. Correct? Actually, it should be smaller one. O is smaller. Correct? Cobalt. CO. COCO4 minus. This is X. CO is neutral ligand. So X plus 0 is equal to minus 1. X is equal to minus 1. So obviously, cobalt is present in minus 1 oxidation state. I think we have 4 options. A, 1, 2, 3, 4. I think third option is correct. What is that now? Minus 1. Okay, well, okay, Kana, I hope you enjoyed this video. Even I would like to make couple of videos for exercise questions alone. Okay, well, so practice it very well. All are conceptual questions. In the next video, we will discuss even more examples. Signing off now. Thank you.